Hi, this is Marwa, and today we have another video where we're going to discuss parallel and perpendicular lines. Now, it's very important to know the relation between parallel and perpendicular lines as an extension to linear equations and right before we discuss systems of equations. We will have a group of questions that we're going to solve together. First, we will discuss the rule of parallel and perpendicular lines. Then we will know how to find out whether two lines are parallel, perpendicular, or neither without graphing. Then we'll see how to find an equation of a line parallel to another line passing through a point or perpendicular to another line passing through the point. So let's see what we have here. Now, we have here two graphs, and these two graphs are one of them are for a pair of parallel lines, like this graph here. As you can see, we have two parallel lines, and another graph, these two lines are perpendicular. We're going to discuss how do we know if these two lines are parallel or perpendicular from the equations in case we don't have the graph. Now, parallel lines, as you know, they never intersect in a point. They're just parallel, so they are going to extend forever without intersecting in any point. There's no point of intersection for them. So it makes sense that these two lines will have the same slope. Well, the slope shows you how steep the line is. So if they have the same slope, this makes complete sense that they will never meet and that they are parallel to each other. So if we look at this blue line here, it has the equation y equals 3 over 2x plus 3. We did discuss in a previous video that this is the slope-intercept form of a linear equation, which is y equal mx plus b. Well, if y equal mx plus b and m here is the slope, and we have y equal 3 over 2x plus 3, then we can tell that m1, which is the slope of the first equation here, is equal to 3 over 2, or the slope of the first line. Now, our second line, this red line here, has the equation y equal 3 over 2x plus 1. Again, if you look at the second slope, you will find that it's also 3 over 2. So what do we conclude from this? We conclude from this that, as a rule, parallel lines, so I know now that parallel lines have the same slope. So if I have two parallel lines, L1, let's say that L1 is parallel to L2, then I can tell that M1 is equal to M2. Because these two lines are parallel, these two lines, and then they have the same slope. What about perpendicular lines? Well, let's check. Again, both lines are in slope-intercept form. So from this line here, the first one, the blue one, we have, I know that y is equal to mx plus b again. Okay, so I can tell that m1, I don't have to write the equation for this equation, is negative 2 over 3. And I can tell that m2, for the second equation here, is equal to 3 over 2. Well, if you take a close look here, you will find that this slope is the negative reciprocal of the next one. What do I mean by the negative reciprocal? Like if this is negative, this is positive. So it's the opposite of it. Not only opposite, but the numerator and the denominator are flipped. So this here is the reciprocal of this one. Okay, what else do I can I notice? I'll notice that m1 times m2 is equal to, well, I have negative 2 over 3 multiplied by 3 over 2. When you cancel, you'll get negative 1. So if I have two perpendicular lines, the rule would be that one of them, the slope of one of them is the negative reciprocal of the other. And also, if I multiply both slopes, then the product would be negative 1. So I can write the rule for this one. And I want you to take notes with these rules, that in case L1 is perpendicular to L2, so these are perpendicular lines, in this case what's going to happen? M1 times M2 is equal to negative 1. This is a rule. Or I can say that M1 is the negative reciprocal of M2. Okay? So you're going to flip it. This is negative 2 over 3. I'm going to flip it and switch the sign. So this is the rule of parallel and perpendicular lines. Parallel lines have the same slope. Perpendicular lines, if you multiply the slopes, you'll get negative 1. Now, how is this useful? Let's see. Now here we have a group of questions, like we have 4 different questions, and you are asked to determine whether the graphs of the given equations are parallel, perpendicular, or neither, and we are going to explain without graphing. So without graphing, we need to know whether the lines are parallel, perpendicular, or neither. Now this first equation here, I can say that M1 for the first equation, this is in point slope form, and we took point slope form in a previous video. So this is y minus y1 equal m x minus x1. So this is m. So I know that m1 is equal to 3. What about m2? Well, this equation was in point slope form. This equation is in standard form. This is the form ax plus by equals c that we took before, and we agreed that the slope in this case is equal to negative a over b. Well, negative a is negative 2 over b is 6, and when you simplify you get negative 1 over 3. Okay, let's say you don't remember the rule that the slope is equal to negative a over b. What do? You just change it into slope-intercept form. How? Like now you have 2x plus 6y equals to 10. Just isolate y. So you're going to have 6y equals to negative 2x plus 10 when you subtract 2x from both sides. Then when you divide everything by 6, you will get that y equals negative 1 over 3x plus 5 over 3. So you know from this that the slope is negative 1 over 3. So it's good to know tricks to help you solve. Like it's good to know that if I have a standard form, I can find the slope by using negative a over b. It saves your time. However, if you don't remember, you still need to know how to solve otherwise, because if you don't, like sometimes you won't be focused enough to remember all the rules, so you need to know how to work your way out. Now we can see here that m1 and m2, if you multiply them together, you get negative 1. And we can see that 3 is the negative reciprocal of negative 1 over 3. So I can tell for this question that m1 multiplied by m2 is equal to negative 1. Why? Because 3 times negative 1 over 3 is negative 1, so the lines are perpendicular for this case. Now let's look at the next question. Now in this question here, for this one, m1 equal negative 2, this is easy. Now what about m2? We agreed negative a over b. I'll keep repeating this until you remember it. So it's going to be negative 2 over 1, which is negative 2. Well, in this case we have the same slope. So I can say that since m1 is equal to m2, then I can say that the lines are parallel. Okay? Let's look at our next question. Now here, I know that m1 is equal to 4, because this is the slope-intercept form. m2 is equal to negative a over b again, which is negative 1, it becomes positive, over 4, that makes it 1 over 4. Now this is 4 and this is 1 over 4. They're not the same. m1 does not equal m2, so they're not parallel. If I multiply 4 by 1 over 4, I will get 1, not negative 1. So they are not perpendicular. Then in this case, I can say without a doubt that these two lines are neither parallel or perpendicular. They're just two lines that will intersect in a point, but they're not parallel or perpendicular. So I found that m1 is not equal to m2, and I also found that m1 multiplied by m2 is equal to 1. So they are neither parallel or perpendicular. Okay, so these two lines are neither parallel or perpendicular. Now actually I gave you this question because some people don't really understand that these are equations of lines. Like y equal negative 7 is a line that is, we call it as a constant, okay, and x equal 2 is another line. Now how so? Well, let's just try to sketch them here. When I say y equals negative 7, it means no matter what the value of x is, y is equals to negative 7. So if this is negative 7 here, well, at this point, like if x is equal to negative 1, y will be equal to negative 7. If x is equal to negative 2, y will be equal to negative 7. If x is equal to 5, y will still be equal to negative 7. So that will make a line, this line here, which is y equal to negative 7. Okay? So this is a line. What about this one? This is also another line. When I say x is equal to 2, so this here gave me a horizontal line, this will give me a vertical line. When I say x is equal to 2, it means no matter what is the value of y, x is always equal to 2. So here at 2, I can say when y is equal to 1, x is still 2. When y is equal to 10, well, x is going to be also 2. When y is equal to negative 3, x is going to be also 2. So this will give you, well, it's not really accurate, but this will give you a vertical line, which is x equal to 2. So these two lines, regardless the rules we know, are perpendicular. Okay? Now, we know that the horizontal line have a slope of 0 and the vertical line have a slope of undefined, and 0 and undefined are reciprocals. However, we can't write it that way. We just need to know that if I have a horizontal line like y equal negative 7 or y equal to any other number, a constant, and x is equal to 2 or any other number, then these two lines are perpendicular. Okay, so now I know that this is a horizontal line and this is a vertical line, then I know that these lines are perpendicular. Okay, so we have seen that without graphing. Usually we do it without graphing. I just gave you a sketch here so you can imagine how it looks like. But you can tell from the slope without graphing whether the lines you have are parallel, perpendicular, or neither. And we have seen a special case. In case you have vertical and horizontal lines, you know that these two lines are perpendicular. Now let's see what do we do when we have a line that I want to draw another line parallel to it or perpendicular to it. It says here, write an equation in slope-intercept form. So your outcome should be in slope-intercept form of a line that passes through the given point. This is the given point, so this is the point I have, okay, and is parallel to the graph of the given equation. So this is the line. This is a line drawn somewhere, and I want to find an equation of another line, not this one, but another one that is parallel to it and passes through this point. Now, what do I benefit from this line? We said that parallel lines have the same slope, right? This line, M1, the slope of this line is 3, right? So M2, because they are parallel, have to be also 3. We agree on that. Parallel lines have the same slope. Okay, and I have a point, this point, the new line that I'm going to find the equation for should pass through this point. Now, to find the equation, the only way you can find it is by using the point slope form. The point slope form that we took previously, which is y minus y1 is equal to m, the slope, multiplied by x minus x1, and we are going to substitute. Y minus y1 here is 3 equals to m, and m is 3 of the second line, multiplied by x minus 1. Now, this is an equation of a line in point slope form, but the question asking you to find the equation of the line in slope-intercept form. So first thing you're going to do is distributive property. So you get y minus 3 equal to 3x minus 3. I'm going to add 3 to both sides. You'll get that y equal to 3x, and this is the equation of the line parallel to the given line and passes through this point. What if I'm asked to find perpendicular lines? This is our last example. It says here, write an equation in slope-intercept form again of the line that passes through the point, the given point, 1, negative 6, and perpendicular to the graph of the given equation. Now, how that given equation will help me? I need the slope. The slope of this line is equal to negative a over b, as we agreed, which is negative 1 over negative 2, which is half. So this is the slope of this line. Now, what is the slope of the perpendicular line? The perpendicular line M2 have a slope of like this one, but the negative reciprocal. You're going to flip it, so it becomes 2 over 1, and change the sign. So your answer is negative 2. You want to check? You're going to just multiply half by negative 2. If it's equal to negative 1, then yes, these two lines will be perpendicular. Now, I have the slope. Do I only need the slope? No, I also need the point. So this is the point, and this is x1, this is y1. Now you substitute in the point slope formula as usual. Then we're gonna get that y minus -6 equals -2 multiplied by x minus 1. You distribute again. Now negative becomes positive. Then you have -2x plus 2. When you subtract 6 from both sides, you'll get that y equals -2x minus 4. And this is the equation of the line perpendicular to the given line and passing through this point in slope-intercept form. Now, I hope this has been helpful for you and explained to you thoroughly how do we deal with parallel and perpendicular lines. We know how to tell that these two lines parallel, perpendicular, or neither, just from looking at the equations by using the slope. We know how to find the equation of a line that is parallel to a given line or perpendicular to a given line and passing through a specific point. I hope this has been helpful for you, and thank you so much for watching.